Yes, and then I would like to welcome you all to this breakfast webinar. And Nabil, he will give us a presentation on artificial intelligence versus real intelligence. We look forward to that. You will mention challenges, opportunities, and geopolitical tensions. So that's very interesting. So then the stage is yours, Nabil. So please.
Thanks a lot. Thank you, Fruda. Yeah, thanks. So hello, everyone. Yeah, thanks really for joining this webinar in the early morning at 8 o'clock. So my name, for those who doesn't know me, so my name is Nabil Belbashir. I am a research director at NORS, Norwegian Research Center, and I am also director in the board of directors of EU Robotics. And today I want to give you some taste about what's going on in AI, mainly in the real AI, how do you call it, or real intelligence. And I will give you some taste about technologies which are developed or going to be developed. Not sure why it went to the next slide automatically. Yes. Yeah, and I will also show you where we can see the future development and what are also the challenges that will slow down this development. So first, I want to say that we have many activities around artificial intelligence. We have machines, robots that can do many things that even human cannot do. So we have like robots like this in Norway that can use specific tasks that for automatizing processes. We can build also a virtual environment like this where we can demonstrate several technology on autonomy, automation, and so on and so forth. And we can even work remotely using some AI technology to do remote inspection like this plant in Brazil and so on and so forth. But we still don't have the real AI. When I speak with real AI, I speak about this general purpose AI, flexible AI, AI that has like a general models that can be used in several applications and so on and so forth. And why about this? When you see like today machines, when you develop basically an intelligent machine to do tasks like this, so they are basically only targeted for their task. But when the circumstances change, when the data change, when the requirement change, and so on and so forth, then you see humans that need to step in, redesign the system, and do it again and again and again for the dynamic environment and change and so on and so forth. And that's not the real AI. The real AI is something that should be flexible, general purpose, and evolving and self-adapting. What is the technical problem about this? Because we have several algorithm methods and so on and so forth that were basically developed. Most of the models are developed in the 60s and 70s that are mainly detecting patterns, establishing association. But what we are lacking now is basically understanding. How can we have systems that can understand situations, that can basically analyze and give a big picture of what is happening, and that's the big thing. So in my talk of today, so I will give you I will give a short introduction. So basically, what is real AI and why do we need it? Because that's something we need if we would like to develop artificial intelligence. So we need to go toward the real intelligence. But there are bottlenecks and gaps, and I will show you quick I would say a summary on what we are working on: self-adaptive, evolving, lifelong learning systems. But also there are many things ongoing in the world, positive and negative, that I will show you that will either further develop this topic or slow down the development. So if we start from the beginning, so when we discuss about AI systems, so typically you have a system, a machine learning system, I call it, where you have neural networks in it. And what you would like to do, you would like to train the system based on examples, what we call data. So you collect many examples, try to train the systems to learn from these examples. But also, most of the AI, I don't speak about the research part, like the basic research where you have this unsupervised part, but the supervised part, you are training this machine learning towards specific requirements. So you have some goal, you have some tasks that you want that the system should achieve, and then you have your requirement. You call it sometimes labels, annotation, and so on and so forth. And goals that you want to set up your system, use the examples and train it. And what we get at the end is basically learnings. In the scientific world, we call them predictions, actually. So when you train the system on a lot of type of data for specific requirement, then the system will be learned, and then you get what you call prediction that can be used, associate this to for a specific output. But we have several challenges. I will not put them all. I will just speak about two main challenges. The first one, which is very intuitive, and you hear it several times, that in order to have this system really replacing or automatizing process and replacing the tough human task, so you need to have it complete and comprehensive. And to have it comprehensive, you need a lot of data. It's not about the volume of data. It doesn't matter if it's terabyte or petabyte or whatever. What matters is that you need the data which represent the larger number of examples, diverse situation. You need all to cover all situation that would happen within the scenario in order to get really a system that have the whole visibility about the context and requirement and give you a prediction. And the second one, which is more practical, basically when you train a machine learning system for specific data, specific goal for specific prediction, when the data change, there is a new situation, requirement change, then what you need to do is basically humans has to go in and take the new data and retrain it and so on and so forth. And of course, if you do it again and again and again and again, you cannot train the machine learning for everything. Actually, it's almost impossible because this process, I have to say, this is the biggest bottleneck, basically, why the AI development are already seeing some break now, because you can train it for a specific data and goal, but the world, it's dynamic. You have many things that change and so on and so forth, and you have to do it again and again and again and again, and that's not how it works. And yes, we have basically this current artificial intelligence works well when you have static data, nothing changed. So you have your data which is clear and so on. Your requirements are very clear, they don't change, and also your prediction are also clear and they don't change. They are very static. So this is how it works. And what is the worst thing, which make it even worse, is that most of the machine learning or AI system, they use also when they do a neural network training, they use the static architecture of the neural network. So this network, it stays actually when they choose it for the first time, when they choose the parameter probably they can change, but when they choose the network size and so on, this network is basically static and stays. And that's also a limitation, because you are not getting dynamics also in the machine learning system. So and this basically, those static aspect of the whole AI, like the architecture and the data and so on, are bringing many uncertainties that you can't automatize process control. You cannot have predictive operation, because the real world is really different. And this is not the real world. This is nice for having it as a research, but not the real world. And this is also a big issue why many of the what we call now AI is not adopted in the real and difficult situation where the human has to step in and so on. You need human involvement. So if we just give an example for the metallurgy, for instance. So basically, when you are doing process control, you are basically producing a material, whatever, aluminum, silicium, whatever. So you are dependent on the raw material type. Sometimes you bring it from Ghana, sometimes from South America, sometimes from somewhere else. And they have different types, different properties. You have different characteristic like moisture and so on and so forth. But also you have a different changing variation in the data, like the process data, temperature, electrical current, and so on and so forth, which you cannot really have control of, and you cannot have the visibility of everything happening there. And this data is definitely not static, besides other type of data, of course. Then the requirement, of course, the requirements you have some requirements which are fixed, but you have also many different type of product that are produced. So sometimes you are more you would like, of course, you would like to have the yield, but you would like to reduce emissions. You would like to deal with the cost. You need to have different grading of metals or metal quality and so on and so forth. And for this requirement, you need to set up different processes for learning. And also the neural network here that you are using. Basically, it should not be something static, because all this neural network depends on the data and depends on the requirement. So we need to have this flexibility in choosing type and size of the neural network, parameter of the neural network, what is the precision and time, and so on and so forth, and so on. And also the prediction, we in order to have adopt changes in the process, we need to deal with dynamics models. It's not like you have this model predictive control, which most of them are static. Of course, there are works toward dynamics, but these dynamics models are basically limited because all others are considered as static. So we need to think about the big picture here in order to have a dynamic, self-adaptive, evolving machine learning. And that's what we say, that when you think about the real world scenario and AI, so we need real AI, and we need a machine learning system which are self-adaptive, evolving to deal with different circumstances, which can be anticipated. This is what I say are all anticipated circumstances, but you have other circumstances that can come and that are non-anticipated, and that the factory has to deal with that for process control. So this is like a big shot. It's a huge, very complex problem, but we have hope. We know that this type of real AI exists, and that's where always we have our the human is the one that is our inspiration. So I show you just how in 1951 the first experiment on humans was made to show this self-adaptive, flexible intelligence. Basically, there is this guy who is called Ivo Kohler. He was in Austria with his professor. So they just did give him a glass which turned upside down the visual scene. Basically, everything which was up will be down, and everything which is down will be up. And it was for 10 days. The first 3 days, it was a terrible situation, because basically just changing orientation of your vision, the whole motor control of the body has to adapt to this. And it was a real difficult situation for him in 3 days. And he need to adapt to different situations. So you see some illustration from 1951, what was happening, how this person was trying to do some small exercises and so on and so forth. But that was really for the first 3 days. It was a difficult part. And then it will come now for from day 3 to day 5. Then the body or the brain start to self-adapt. And basically he was almost doing everything, and it was normal. So he was able to adapt to the new situation, the motor control, and so on and so forth, were adapted to the new situation, and so on and so forth. And after 10 days, it was a perfect, I would say, as nothing changed before. And that's amazing capability of intelligent machine, which is the human here, that could adapt to the new situation. And of course, when they took the glass back, then it goes back to the same situation as it was before. But also interesting, you can notice this in the small kids, basically 1.5 years old. So you see this kid, basically. So in this situation, you see that the kid, he was not trained for this situation. It was an unexpected, unanticipated situation, but the human intelligence is able to take decision even for situation that I didn't see before. And that's amazing for the kids 1.5. There is a lot of videos around 1.5 years kids, how their intelligence is developing, and it's amazing examples about this. But in general, when we speak about like general purpose AI or real life intelligence. So we would like machines that can explain situation, understand situation that they see. We would like a machine also that can imagine what we don't see, but also they should we would like also machine that can make plans and solve issues to make what was imagined as real. And also what is very important, all machine learning systems are based on models. So we would like, and for every new task you have a new model, so we would like to have a general purpose model which can be built on the go by machine. And when we have this and we have real AI, we can have machines that can really do the hard jobs that humans are doing. So why we need the real AI? So there is, I would say, a thought in the society that when we have AI, when we have robots, then we will lose our job and so on and so forth. But that is really a completely biased situation. So we need the real AI, we need robots, we need machine and so on and so forth, because basically the global challenges like the increasing world population, the increasing infrastructure that we are building, we are not possible to be managed by human alone in the future. If you just think about the energy infrastructure and the renewable energy that we are building or the countries are building, so it's still by far not replacing the fossil energy at all at the moment. And especially when you think there are like more than 500 million of people around the world, they don't have electricity, like more than 3 million in Africa, 300 million in Africa, and so on and so forth. So there will be a lot of energy demand in the future and so on and so forth. And you need to build infrastructure and so on and so forth. And those infrastructure, you need people to go to the field, to operate them, to maintain them, and so on and so forth. You need automation. You need we need to have robots that can do the work that the human is doing now in this very tough environment. Otherwise, we will not be able to manage our infrastructure. And that's really, really important, that real AI has to be the solution for the future. The second, also the food. Actually, we know that world population is increasing. We have the amount of arable land is decreasing. So now we are going into ocean, try to explore ocean to get agriculture, but also aqua food or aquaculture. There are plans about having like this DNVGL of have this multi-purpose offshore platform. There is plans also to develop a large, for instance, extremely large fish cages for farming outside and so on and so forth. Those are all infrastructure which will be put in a very remote area, and you need really automation, autonomous system, real AI that can help to operate them and monitor them without human in the loop, because that's not possible to be done with human all time. And then, of course, the other one other example is the waste. We have a big issue with the climate, but also a big issue with the environment. And we can just see we are not able to manage the waste now. So when everything is increasing, like the energy demand, like the food demand and the consumption demand, but also the human demand, the amount of land is decreasing, a space to store waste or to destroy waste. So we need to think about recycling, we need to think about remanufacturing, about waste management, and so on and so forth. And this all, many of those waste management are done manually now. So we need also real AI that can help into this waste management. So if we want to achieve real AI, like technically speaking, what we need to do basically, so we have to mimic the brain in sensing and learning. And when we just think about it, the human brain has more than 80 billion of neurons. We have 5 main senses, but we have about 10 other senses, and each sense is using several types or a big shot of neurons in our brain. And we need to have intelligence in sensing such that can be replaced by machines. We need also to have this sensing, but also learning. We need to have self-adaptation. As I said, our brain is not static. Our brain also the neuron, we have neurons that die and new neurons that can be built up, what we call it plasticity. So this is like, it's very dynamic in our brain, and that's something that we need to work on toward the real AI. But the second topic as well is about computing. And that's, as probably most of you knows, that most of the AI models are used from the 70s, but the computer, the access to the large computing capacity, it's one of the main reasons why it is now worldwide, is democratized. You have a very strong computer already in your mobile phone. And but still we are far away from what the brain computing is doing, basically, because you have, as I said, 80 billion of neurons, and every neuron has more than 1,000 of synapses, which are the interconnection between the neuron. We speak about a small object which is 1.4 kilo, which has 20 watt, and even those big computing centers that are built worldwide, they don't even ensure 1% of what the brain can do, though they cost hundreds of millions, and they consume megawatts, and so on and so forth. And that is the future, or what is now the main issue, is how to assure a resource efficient neural computing and learning without using this very, very strong hardware to develop neural networks which can basically be much more efficient in computing. Yeah, that's just a quick like, this is like a dream. It's that we worked on, is to have this lifelong learning, visual learning. So what we would like basically to do is to send the drone machine with the camera, and we don't tell the drone anything. We tell the drone, let me what you see, so they can develop and evolve over time and understand what is in the scene. And then we are trying to let the drone tell us where are the person, forest, land, and hill, and so on and so forth, without anything like a priori knowledge, and so on and so forth. And this is really the way to go, and this is where we can achieve the real AI. So there are many scientific challenges. To go to the next scenario, it's like the scientific challenges is like, we have, when we speak about dynamics, I spoke about static data and so on, but when we speak about dynamics, we speak about many scenarios, which are large and heterogeneous, so we need to deal with them. But also we speak about complex requirement and goal which have conflict, like when we say we need to be resource efficient and flexible, but then you need to have a lot of data. So it means you need to use a lot of space in order to be robust. So how to find the trade-off between the goal, how to deal with dynamics of the goal changing over time in runtime, how to deal with machine learning systems that are aware about their state. So if the machine learning knows how intelligent they are, how good they are, then they can also basically evolve. How to deal with neural network or architectures that can be dynamic, that can also increase or decrease as the human brain is doing, and so on and so forth. And how basically we design the self-aware systems. And that's what we work on, something called evolutionary neural network, which has dynamic architecture. Very quick here. So it's about two nodes that are like the main foundation of this type of neural network. One is called self-aware node, which is about awareness about the evolution of the network, and one is self-expressive node, which look at the goal requirement and the dynamics and try to manage them. And this all form what we call it proprioceptive nodes, combining both nodes, and build what we call it evolutionary computing system. And there are some publications that you can look at it later on. So if you are more interested on this evolutionary neural network and computing system. And this is really important to have this. There are some activities where we are working on this, like how to make this dynamic lifelong learning for operation and maintenance of like oil and gas, a renewable energy infrastructure in aquaculture, and process industry and manufacturing. And that's because, as I said, the future, we need this real AI in order to replace human in those tough tasks. Now the second part of the talk is when we see real AI what are the challenges and so on. It's very interesting to see what are the investment and what are the direction, what the people are doing around the world. And this is like basically the military. The military is, I have to say, there are a lot of course, drawbacks of military research, but there are a lot of also advantages, which because they are bringing basically research further, they are more targeting performance. And if you, I don't know if you watched the news in 2018, for instance, 3,000 people at Google, they did protested because they didn't want to work on this Maiden project, which is the Pentagon AI project. It was 250 million US dollar at that time. So they wanted to basically improve the drone strike, and they wanted to get an upgraded TensorFlow. And of course, the people didn't want to use this for the wars in Middle East and so on and so forth, and they protested. And it was about 250 million US dollar. So that's basically peanuts of the budget of the military just in the US, which is trillions of dollar. Because when you look back between 2004 and 2021, like the US military invested more than 44 billion just for the big five, like you have Amazon, Alphabet, which is the Google mother company, Meta, which is Facebook, Apple, and Microsoft. And just to see what are the biggest development that is happening, which we are profiting now from them, you see them in the military. Like Amazon is the official partner for the military research, and they hired best people in the world to do this, especially those Amazon Scholar, probably you heard about it. And all the cloud service of Pentagon and so on and so forth are using Amazon. But also interesting things, you see this face recognition software that people are using, and it's amazingly working. It was developed basically in the military. And also you see Microsoft, they are trying to push Azure, but also the HoloLens. And the interesting thing, the HoloLens is a big failure in civilian. So they like the mixed reality. And you see a lot of companies which have developed this glasses, virtual glasses, like the one that was bought by Snap. They went bankrupt, and HoloLens was almost bankrupt and so on. But 2021, the military gave 22 billion US dollar, and we can meet again in 2024. You will see magics out of this HoloLens development. But last but not least, so Alphabet, which was the Google one, they basically the people in Google didn't want to work on military, but Google now created what you call Alphabet and Google Venture, and they are using a lot of spin-offs company like Orbital, Clarif AI, and so on to make development, and they are also working on a real AI as well. And that's not new, because we know that IBM was a very important partner in the Second World War with this punch card. The whole University of Stanford was developed by military investment in AI until the 70s, until they protested and they wanted to stop investment. The internet was created in the military when the ARPA, which is now the DARPA, was using this inter-office communication, but also many of military, I would say, technology department like Lockheed Martin, they build their missiles in California, Sunnyvale, which is exactly between Apple, which is in Cupertino, and Mountain View, where Google is located. But this what we saw until 2021, the investment is much less than what is coming up now, 2022 and up, because we see, because of this conflict, many investment. But interesting now that there are a lot of startups company, you never heard about them, and then you see they got $1 billion US for developing like anti-drone system, defense system, like Anduril. Skydio, for instance, got in February 2022, which is a small startup, like $100 million US for building drones for the US Army. And then this is, for me, the biggest surprise, C3.ai. It's really a tiny company, a startup. They got $1 billion US from the Raytheon technology company for making what we call it long precision targeting. It's machine learning in order to improve the targeting of objects. and so on and so forth. And also, of course, Palantir, which is the company, a small startup, even they won against Raytheon military contract of about 20 billion US dollar in order to build intelligence system to assist soldier in the field. So for me, when I would like to look at a new technology, I look at those topics because I know they don't, of course, the bad side or from the ethics and so on, they don't have those ethical restriction and so on and so forth that you have it in civilian and so on, but they are, which is bad anyway, but it's very interesting to see how they can make technology really happen. But then there is this. It's a pure U.S. domination. We have to say it in this real AI development. There is nothing, but there is a big threat where the U.S., like many U.S. officials, they have sleepless nights. You can see it in The Economist and so on of this leadership because of China, and this is very bad actually for the research and development, because what happened just 2 months ago now, on the 7th of October, so the US government announced what they call it a national security strategy. It's basically they are forbidding export or having control over the export of all advanced computing semiconductor technologies that are building AI or computing or machine learning and AI to China. And they start to make this into the start of this sanctions, actually, or embargo, we can call it, is embargo, is from the 21st of October. So it's already 1.5 months ago. And they put 4 shock points. And this is basically this 4 shock point. I will go one by one. It's the last 4 pages. They are basically killing AI technology development in China because they want to stop military and economical growth. They are very afraid of their development, but also they are stopping or killing some opportunities of development for the whole world, but opening other opportunities, of course, yeah. And but before this happened, actually in 2015, in the Obama time, US basically has forbidden to sell like processors to military organization in China, and this was for Intel. And then what they did, they found out like 1 year ago that all military I would say offices or machines in China, they are controlled by Xeon processors, and this is because there were a lot of Chinese civilian organization which was created just as a pro forma, so that they buy it like from the US and then sell it again internally to military in Chinese. But then the second one was this Huawei, which is really a proud of China, like the big technology developer, which was the world's largest smartphone and communication provider in 2020, and it's really killed. You don't hear anymore, like you don't see them even in the top 10 companies of smartphone, and that's was done. But it was also very interesting that Huawei, like, they create several side companies where they use Huawei technology to take over, and that was, yeah, there are 2 or 3 companies like Yangtze and several others, Huawei Marines, which was sold to another company, and so on and so forth. And they are trying to, how to say, again, stand up with a different name, but that was also like the US government saw that was not enough actually to stop this Chinese development. But the biggest thing which triggered this export measure of October was this one. Basically, China has the big strategy to build what they call it the East Data West Computing Center. It's the largest computing center in the world, with 8 computing hubs, 10 data center clusters, billion of US dollar for creating this. And this will give a huge capability for AI, because you can do quick calculation, computing, and so on and so forth, and develop several technology and make it open for different companies in China. When the US saw this in July, basically, the first thing that they did, they said in August to NVIDIA and AMD to stop shipping AI chips to China. So NVIDIA, there is these two companies which are equipping basically the computing center, and especially NVIDIA one, the A100, which is huge, like the GPUs with billions of transistors. And of course, they are bringing now the one which goes H100, which is 100 times or 150 times even faster than the A100. And the US government told NVIDIA and AMD to stop shipping this. And AMD, they have the EMI 250. It's a big loss for NVIDIA and AMD. And the government told NVIDIA they will pay them the billions that they got. I'm not sure if they did it, but it was a big loss. And that was a huge shock for the Chinese government, because without this, they cannot build those East Data West Computing Center. But then they started with this national strategy in October, and they have 4 shock points. So the first one, they are forbidding basically all companies in the world to sell advanced chips like computing chips to China, to civilian and to military. And when we see advanced chip, is all chips which are above 16 nanometer, below 16 nanometer. We know that at the moment we are at 3 nanometer CMOS technology or process, and then they want to stop it at 16. So it's basically 4 years ago, which was invented this chip, and they want to stop it. But then China said, okay, China can basically, they don't need to import, they can develop it themselves. And the new US strategy thought about this, and they said, okay, we know that they want to develop it themselves, and they created the second shock point. So we know when you want to develop processors or chips for computing, so you need to use software. So you have 2 types, you have 2 steps in chip development. One is the design, and one is the production. And for the design, you need software, and there are several software, or basically the 4 main softwares in the world that can be used for making these chips happen. And that's called, they're called electronic design automation. And you have 4, is Cadence, Synopsys, ANSYS, and Mentor Graphic. They are all American. And they said it's forbidden for Chinese company basically to get access to this chip and to use this design software for making the chip. And at the moment, there are more than 28 companies in China that they are using this software. And even if they have the license of this software, they cannot use it because it's now forbidden. So they are not able to design themselves. And they have to create their own, of course, design automation software, which may take years, if not decades. But then they said, okay, they can try to get somebody else doing the design for them, and they can produce the chip themselves. And that's also the third shock point where the US strategy thought about it. So to produce chips, you need machines like this. Sorry? Somebody... okay.
Kanskje det, ja.
I hear somebody talking.
Tror jeg det var noe sånn på Facebook.
I heard somebody. Okay. So to build such a chip, you need machines like this, and you have the 5 big companies in the world. You have the biggest one is in the Netherlands called ASML, and then you have in Japan the Tokyo Electron, which is the second one, and you have 3 in US. And of course, they are forbidding also companies basically to sell those chip making machines to China. And that's amazing, but not completely all the chip. They have some limitation, like for the chip making logic chips with 16 nanometer or below, the DRAM memory and or below, and the flash memory of 128 layers or more. So basically going back to 2011, where you have this old machine making at specs below the specs. And of course, this SMIC, which is the biggest semiconductor factory in China, they have a 14 nanometer already since 2019. They bought it from ASML. Now it's basically obsolete. They cannot use it because ASML is not allowed to maintain this chip anymore. And if they need component to it or maintenance, they will not get it. So they will basically stopping production with those technology, and they have to go back to the to the machine that they have from 2011, which they can produce a very, very old chip. And even if China think, okay, they can build those machines themselves, this is also a problem because there is this what they call FDPR rule. Many of those machines has components which has patents in US or a component belonging to American company, and they are not able, or they will not be able to get those components. So they need to really to start from zero, which is 50 years ago, because many of those components are really, really old, and they are proprietary of US company, either directly or indirectly. So it's almost impossible to make it. And the fourth one, which was the one where the minister in China was expressing his concern, is also the know-how. That's the fourth shock point, what they said that US American citizen or people who hold US green cards, which are working basically in the 16 Chinese companies at very high grade, they are not allowed anymore to work in China, so they have to leave China immediately. Otherwise, they will lose their citizenship and the green card. And that's the biggest issue, because to operate or to build knowledge and so on and so forth, you need expert people and so on and so forth. And that's this one is really locking from all over the situation. But what will be the impact in the short term and midterm? Wait and see. There are many things, but there are a lot of opportunities, because Europe, seeing this type of issues, they are also creating what they call it European Chips Act, where they want to develop their own technology and so on and so forth. There are several opportunities in Horizon Europe. I see that I am almost 2 minutes before time. Probably there are some questions, so I will just stop here, and then thank you for attending this webinar.
Thank you, Nabil, for a very interesting presentation. Then we will open up for comments or questions.
Just a little Norwegian reflection on your story that was on this experiment on the upside down glasses. We have a Norwegian version of that with a famous television program that was run, I think, in the 70s or NRK, called Fysikk på roterommet. So I think a number of people here recognize that. So they did the same experiment there. What you said actually was that when you take the glasses off, well, you get back to normal. What they hadn't really reflected on was that it takes you also 10 days to go back to normal. So they had some fun perspectives on that in this program, that they hadn't taken that into account in their planning, because that was part of it, the same transition. So, but of course that was done in the 70s based on this. That's a little Norwegian anecdote on exactly that. And my uncle was involved in that, so that's why I remember that story.
Excellent, Arne. Can you send me the link or something? Or that
Yeah, I can do that.
Very. I didn't know about this. That's very good. Good reflection. Thanks a lot.
Fun Norwegian thing.
That's very good. Yeah.
Very interesting. Thank you.
Good. Yeah. Thanks.
Thank you, Arne. Any more comments or questions? You delivered this just on time, Nabil. That was impressive. So we have still some minutes then to discuss. No, doesn't seem to be any more comments or questions. Then again, Nabil, thank you for a very, very interesting presentation.
Thanks.
Okay.
Thank you very
Bye
much.
then.
Yeah. Thanks you. Bye bye. Thanks. Bye bye. Bye.